Hey everyone, this is Matt with Learn Everything About Design, and in this video, we're going to dive into plasticity curves. So we recently redid some getting started content, one for users coming from other programs like Fusion or Blender, and then one for the absolute beginner. And one of the comments was around curves, getting sort of more information about how curves work, how to deal with certain situations. And while we can't cover everything in one video, hopefully this video will answer a lot of those questions and help the new users understand how to work with curves and plasticity. So before we get started, we are going to hide the default cube and then hit / on the keyboard. There are a lot of different areas that we want to focus on, and we're going to start with construction planes. So construction planes are going to be the foundation of using curves inside plasticity. While it isn't strictly required, a basic understanding on how these work and how they impact or affect your curves is extremely important. So if you have a keyboard or a laptop with a numpad, you can use 1, 3, or 7 to get to these different default views. You can also hold down Control and use 1, 3, and 7 to get to sort of the inverse. So 7 is top, Control and 7 is bottom, for example. So if you have those available to you, that's probably the easiest way to get to some of these default planes. However, on the right-hand side, we've got this section where we have construction planes. By just clicking on XY, for example, we've now activated the default top plane. We can double click on this and this will go to a normal view. If we hit the X, we'll be getting out of that view and we can go back to whatever sort of isometric view we want. Why is this important? Well, when we're creating curves, generally we need to have a 2D closed profile. If we want to turn it into a solid body, it has to be in 2D. In order to make that happen, working in construction planes, whether they're created from a planar face on an object, or if they're created from the camera view, for example. When we're working in these temporary construction planes or even saved construction planes, then we have a good idea or a good sense as to where our curves are being created. So let's take this for example. Start with the line tool and just create some sort of shape. Doesn't really matter what it is. We can snap to the x-axis or the y-axis, snap back to the end, and then we'll hit X to get off of our construction plane. So as we rotate this around, we can see that the shape that we created is planar. It's 2D, which means that we can turn it into a solid, and it goes directly through the origin. The reason this is important is because the plane from camera, by default, will go through the origin. You can also do it at a specific point or distance in space by using Control, Shift, and Space. But the basic thing here that we want to understand is that creating these curves in 2D, whether it's on a temporary construction plane from your camera view, or if it's on one of the default XY, YZ, or XZ, that is the default workflow that is going to be the most important that you understand as a new user as you're just getting started. There are plenty of cases where you want to create curves in 3D. Maybe it's for a path for a pipe or a sweep or something like that. And you can certainly do that. So for example, I can start over here on the x-axis, then I can come up and snap to Z, I can come back here and snap to Y, come back over here, and then I can finish that. Now the problem with this is that is in 3 dimensions. It is not planar, which means I cannot use it to create a solid object by the normal means, like extruding, for example. And because of that, we need to be very careful how we build these curves in space. So using those construction planes are going to be important. Let's go ahead and click on this and just delete it. And let's double click on XY. So now we're looking top down. We're basically looking along the Z axis and we're pointed to the XY plane. Now the XY plane or top plane is going to be where we're going to do most of our work in this video. So now that we have a basic understanding about construction planes, let's talk a little bit about open versus closed profiles. Once again, we're going to start with the line tool. I'm going to start at the y-axis somewhere, come off to the left, come down to X, and then hit the 0 intersection before we right-click and say OK. This is an open profile. Now, open profiles can be used for all sorts of things, right? So you can create a sheet or a surface, you can thicken it into a solid, but it can't directly be used to extrude a solid cube or block, for example. We do have the option to close it off either by creating overlapping curves. Now we've got this closed profile region, or by simply finishing off its endpoints and creating that closed profile. Either of these are going to be fine, keeping in mind that the overlap works just fine as long as the curves are visible. As soon as that curve is hidden, then you won't have that region. But now we've got this closed profile. We can use it for an extrude, we can select it and pull it up into 3D. Currently, it is set with two different polylines. There's a single line here, and then there's a combination of 3 lines on the left side. So this brings me to the next topic, and that's joining and unjoining. Now, the reason that you want to join curves together is, let's say that you want to add fillets to all the corners. Now, there is a fillet tool. You can hit B for boy on the keyboard, or you can select this. And keep in mind that as we do this, only corners that belong within the entire set of curves are going to be filleted. You can see the ones on the right are not added. And the reason for that is because they're not joined together. We can't round those corners off because they're independent of each other. So what we would want to do is hit escape in this case, hold down shift and select this other line, and then use join. Now you can also do this by hitting F on the keyboard and finding the join tool. So you can search for it here. So now that everything's joined together in one polyline, if once again we use the fillet tool and we start to drag this, you can see now all 4 corners are included in that. And again, this is an important thing because as we build out these shapes, we can do this with multiple different lines, and joining them together gives us options like doing this, adding fillets to everything. So let's go ahead and right click to accept that. In this video, we're specifically talking about curves, but tools like join and unjoin work on solid bodies and sheets as well. So keep in mind, a lot of these tools, when you use F on the keyboard and you search for them, will have options like join curves and join sheets. The join tool, sort of the top level of that, will work based on your selection. So if you have curves selected, it'll join them together. If you have sheets selected, it'll join those together into a single sheet. So just keep in mind, a lot of these tools will be sort of based on whatever your selection is. Next, since now we have a little bit of an understanding of the construction planes and the basics about creating an open or closed profile, joining and unjoining curves, I think we should probably mention grid snaps. This is something I do not use personally, but a lot of people do like to work with grid snaps. You can toggle this on here, and you can change the grid snap amount. So in this case, if we do 50 millimeters, notice that it changes the grid in the background. What this allows us to do is snap to those positions on the grid, and this can help you, especially if you're building objects at a specific size. You can use the grid snaps to your advantage rather than having to manually enter dimensions. If I turn grid snaps off and I start this over here, let's go ahead and let's just zoom out a bit. So if I do this over here, I would have to hit tab and type in 50 millimeters, tab and 90, and then I would have to left click and I need to come over this direction, and it just doesn't quite work the same. So grid snaps can be very handy in some cases. I personally don't use them very often, but again, they can be pretty helpful depending on what you're trying to model. Again, let's go ahead and delete that because we don't really need to see it. But with grid snaps, we also probably want to talk a little bit about snapping to objects. So I'm going to bring back the original cube and zoom out a bit and rotate this around and cancel out of that XY plane. The reason this is important is because notice next to the cursor, it says face, and as we get closer to snap points, it says center, face, and Z. This is allowing me to understand exactly where I'm putting this in 3D. If I left click, I know that is in 3D at the top of my cube. If I come back here, you see it says closest edge face intersection, mid perpendicular Y. So this is telling me that my line is perpendicular to this edge at the midpoint, and we're moving in the Y, we're sort of projected to the Y axis. So I'm going to left click, I can come over to this point here, but then as I start to build out in space, I am no longer snapping to anything until I go back over to these objects. So again, this can be tricky because we're building things in 3D, and then we no longer have this sort of 2D profile that we can use for extrudes. If you select the 3 dots next to object snaps, note that you can toggle on and off certain things, so face, curve, shell edge, and you can enable or disable those snap options, and sometimes you may have to, depending on where you're trying to create these curves. If this happens to you, we do have a trick that we can do to get this into 2D. So what we're going to do is use the scale tool, and we're going to scale it in a single direction. In this case, we're going to scale it in Z. but we want to do it based on a reference point. So for example, if we want everything to be in line with this top edge here, what we want to do is reset the pivot point, which is V on the keyboard. So I'm going to say V on the keyboard, snap to this location here. Now you can see it's kind of changed. Now we're going to be scaling in Y. So over here, we want to set Y to 0 and hit enter again to accept. So what this allows us to do is take all other points in this polyline and scale it to whatever our reference 0 point is. So using that pivot point, setting it somewhere that we want, we're able to scale this entire thing back to be 2D. And now it can be used as an extrude profile, for example. So again, if you do happen to mess up and you end up with something in 3D that you really didn't intend, there are ways that we can fix that. So now I'm going to select this polyline. I'm going to use the / to zoom in, but then I want to go back by double clicking on XY because I really want to work in this sort of top-down orientation. Now we've looked a little bit at just basic snapping to XY. We looked at grid snaps, and we also looked at snapping to objects. There are other sort of projected snaps we need to understand. And those projected snaps come in the form of some pink lines that you see on the screen. So we're going to do a couple of examples here. I'm going to start by creating a couple circles. I'm going to just do one over here and zoom out a little bit. And then I'm going to start with the line tool. So when I select the edge of one of these curves and I go to the next one, there'll be a position where next to our cursor it says tan/tan. What this is allowing us to do is change the tangency position. You can see that it happens down here as well. It's changing the position of the starting point of my line, and it's going until it satisfies tangency on both of these curves. So I'm going to left click to accept. And now what I've done is I've created a curve that's tangent to both of those edges. I'm going to right click to accept, and then I'm going to start another line. Now if I come up here and just pick a random point, there will be a position where I have tangency with that curve. You can see the pink projected line. And if I kind of move this around, that's going to go away and it'll snap back until it's like horizontal or perpendicular to Y in this case. So there are those positions that you'll just find when you're creating these curves. I'm going to go ahead and snap here, and then I'm going to come down and find tangency on this, right click to accept. So now this line here is tangent to both of these circles. It's tangent at the top, tangent at the bottom, and I can add a fillet and round off this corner if I wish to create this sort of closed profile. And I can continue to do this until I find these sort of tan locations. And sometimes they can be harder to find, but make sure that, again, you remember we're working in a construction plane, we're looking top down, and we're using these references, such as these curves, to help build everything out. Once I'm happy with sort of building it out like this, again, I can use these profiles however I want now. I can also use tools like trim, and I can trim away some of these interior sections that I maybe don't need. And then I can select everything here and I can join it together with the join tool. Now remember that when you box select, you may be selecting edges, control points, as well as profiles. You may want to go ahead and look at your edge selection and just do an edge selection tool. Then we can use the join tool, and then we can go back to all selections by hitting 5 on the numbers or tab. And then you can see here now we've got one closed region. It's all considered one polyline. That's taken on the name circle because that was the first object in that sort of selection, but it is a grouping of lines and arcs to create our closed profile. So that is important as those are sort of the default snaps. But there are some other snaps that we can get to by using the shift key. So for example, let's say that we started down on the XY axis, but we want it to be parallel to this line. We just need to hover over that line, tap the shift key, and then it's going to give me this parallel extension. So I'm going to go to that parallel extension. I'm going to come up vertically. And let's say that I needed to figure out where this point was in space. I come back to the point, tap shift, and I get this sort of vertical projection. Then I can come down and right click to accept. So using those sort of temporary projections is another way that we can make geometry reference something else, whether it's a tangency reference or a parallel or perpendicular reference or so on. And again, another example, let's say that I want it to be horizontal with this line. Tap shift, and now I've got this horizontal reference. I can intersect with this line here, right click, And again, this creates these sort of closed profile regions that I can use. And now I know that this edge here is horizontal or collinear with that edge. Some cases you might find that you maybe need to extend an edge or move it, and there are tools for that. They don't quite work the same way that you would expect, but you do have an extend option. Again, F on the keyboard, you can see that we have extend edge. And if we do that and select an edge, so we'll go to extend curve in this case, we can make this line longer. Oftentimes what would happen, I'm going to hit escape for this. Oftentimes what would happen is if we want this point to connect here, we either need to just draw another line, or we can take this endpoint and use move. Again, we've got options like resetting our pivot point, which can be extremely helpful. And in this case, freestyle, which is F on the keyboard. F on the keyboard lets us pick our starting point and our ending point, and then we can right click and accept. So this line is still horizontal. It's still collinear because that's how we originally drew it, but we just simply moved that endpoint. Now let's say that we wanted to move this entire object. So G on the keyboard, or you can click here, but we want to make sure that it stays the same distance away from this original object. A way that we can do this is by using V to reset our pivot, and we'll just place our pivot somewhere that has the X, Y, or Z axes along that direction. So that way we can move this up and sort of drag it around. The next thing that we may want to do is move a line or move this point. So again, G on the keyboard, I'm only going to move in the X direction. So I'll hit X on the keyboard. And then if I hold down the Control key, that will let me snap to other geometry. So again, very similar to how we moved it over here using the pivot point, but in this case, holding down Control let me create that snap. And I'll do a simple example here. I'll draw this line. We're going to use G to move it, X in only the X direction. And when I hold down Control, it'll snap to various locations. So for example, if I needed to snap to the midpoint of the circle, I could snap there. I could take this endpoint G, Y and move it up. And now I've created these sections that perfectly go through the center of that arc. And again, this is just by using a couple of these shortcut keys. Control while you're dragging will let you have that snap option. Tapping Shift will give you those extensions. And also using options like Move and Freestyle or Move and Pivot Point can give you the control that you need to make sure all these curves are sort of lining up how you would expect. So we've covered quite a lot so far. I'm going to delete some of these lines I don't need. I'm going to delete this entire object here. There are a few more things that I do want to mention or want to talk about a little bit. We've already talked about things like trimming and extending. We've talked about moving lines around and snapping them to different places, but in some cases, you may actually want to rebuild a curve. Now, you may not know what that is, but let's go ahead and explore it. So if I select this shape, I've got two main options here. I've got rebuild and I've got raise degree. Let's take a look at rebuild first. When I click rebuild, what this is going to do is it's going to rebuild basically the entire polyline, in this case, the lines and arcs, based on a couple of options. One is a refit tolerance value. It's going to fit within 0.001 millimeters. We can also dictate a number of points. We can increase or decrease this, and we can use what's called explicit control. Now, explicit control allows us to increase or decrease the degree and the spans. So what this means is this is going to be basically converting each of these lines to a spline or a CV control spline. Now I'm going to hit escape in this case because I also want to talk about raise degree. These tools are very similar in nature. Rebuild gives us a little bit more of fine control. For example, the tolerance to refit, say, a spline with a new spline. Raise degree is going to take each segment and divide it in half. So for example, this line here now has a control point in the middle. I'm going to use G on the keyboard, hit G a second time, and pull this out so we can see it. So this curve here was divided in two, and it originally was a line, and now it's a spline with a control point in the middle. If I use raise degree again, what that's going to do now is it's going to take that sort of curve, that spline that had a control point in the middle, and now it's going to have three segments, so two control points in the middle. And as we keep using this raise degree, we're going to keep adding these control points. This raise degree tool also works on surfaces or sheets, but I believe that on sheets, surfaces, or solid bodies, that it's only available in the studio license. I don't believe it's in the indie license. But on the curve side of things, I do believe that it works in indie and studio as well. So you may be thinking, why on earth would I need to do this? Well, if we take a look at creating a spline curve, sometimes you might build something out in space and you may just have way too many control points. And using things like rebuild, we can use the number of points to reduce the overall number of points we have while still trying to keep it similar in shape. We can also, again, do explicit control, or we can do a refit tolerance. So using those options is a great way to take a bunch of different splines that you may have created that maybe just have too many internal control points and smooth them out. Using raised degree in this case is only going to add to the control points, which makes control a little bit harder. So it's probably going to be a less practical case. Most of the time you use raised degree on a sheet or a surface, but it does have its place in some cases on curves like this. So I don't really need this curve, but let's go ahead and delete that. And let's talk about maybe one more thing that I think is important that we mention. I'm going to go ahead and delete both of these actually. So I'm going to start by holding down the left mouse button and then just creating a 3-point arc. So I'm just going to create one over here. And I'm going to repeat the process again over here. And then I want to take a look at bridge curve, but also loft. So bridge curve is a way for us to bridge one curve to another curve. Now, you'll notice that things got a little funky here, and that's because by default, it tries to trim. And generally, you can turn that trim option off. The reason that trim is available is because you can actually move this to different points on the curve you select. And I'm going to hit escape to show you this. So again, if we use bridge curve and I select maybe back here to here, what this is actually allowing us to do is trim away those sections from where we selected. Now, this is also allowing us to go to the end of that original curve, so we can go to 100% and 0% respectively. Bridge curve lets us use G0, which is connected, G1 continuity, which is tangent, G2 continuity, which is going to be curvature continuous, and G3 continuity, which is typically considered like a class A. Generally, what this means is going to be the number of tangency control points you have. So G0, for example, is just a straight line between the selected points. G1 is going to be tangency, which is going to be controlling the direction of curvature at that intersection. G2 is going to add an extra control point to each side, and this is going to take care of not only the tangency direction, but also the radius of curvature at the intersection. And then G3 is also looking at what's called the acceleration. So not only is it looking at the tangency direction and the radius of curvature, but also the rate of change. Now, in our example here, I used arcs, which are curvature continuous. They have a radius value that's constant across the entire thing. But if you had a complex curve like a spline, that would be a different story. So I'm going to right click to accept, and notice that this is now a new curve. I'm just going to move it out of the way. And the reason I want to mention loft is because we can actually go between these two curves here and use L on the keyboard and create a bridge vertex. Now, L on the keyboard is the loft tool, and this is what we would use to loft from one profile to another. This would create a surface or a sheet. If it's closed profile, we could create a solid. But in this case, you can use the same thing to create a bridge vertex. All right, so when we think about this bridge curve and bridge vertex, they're very similar in nature. The input selection is different. Bridge vertex works by us selecting control points. So for example, here to here, and let's go ahead and select this one and hit L. So this allows us to use the sort of bridge vertex to create a curve that goes from one point to another. Now it's still looking at tangency, it's still carrying that tangency around, but it's just a different method here. Now I'm going to go ahead and delete that last curve, and I'm going to use bridge curve to go from here to here. And notice that the direction is backwards. So we need to flip it around. And again, we can go to 0 and 100 here, and we can control the curvature continuity independently of each of those. But again, it's giving us a very similar result. But what you're going to find in some cases that the bridge curve is going to give you a better or more accurate result because it allows you to determine where on those curves you can actually decide to place it. So for example, let's say on maybe this left side, I wanted it to be maybe about halfway through. So I could go to about 0.5, but the bridge vertex is going to require us to go to the end of the original curve. So in general, the workflows in plasticity around curves revolve around construction planes. So understanding the basics of construction planes, knowing the differences between open and closed profiles and how to work with them, how to use join and unjoin to put certain aspects of the curves together for things like doing a fillet or doing a chamfer, working with snaps, whether it's grid snaps or using control during drag to snap to objects or tapping shift to get those projection snaps, and also understanding the options you have for things like the move command. When we're using move, and we can reset our pivot point, or we can use a freestyle move to say, go from there to there. That's going to be very important as you begin to build these complex curve networks and you're trying to combine them all together. Using things like rebuild and raise degree, some other tools like extending and trimming curves, and also doing things like bridge curve and bridge vertex. Now, there are many other topics and subjects that we haven't gotten to, but hopefully this gives you enough of a basic intro on how to work with curves at the sort of beginning level, and also gives you a little bit of insight into some more of these advanced tools like raising degree or rebuilding curves, and also doing things like bridge curve and bridge vertex. Now, if you have any questions on this or want to see more, then please leave a comment below. Remember, if you are looking to purchase Plasticity, we are an affiliate channel, so you can use the code LEAD10 at checkout. That'll save you 10% off. But for now, I think that's as far as we're going to take curves. But if there is, some response and people want to see more or some more examples, we can certainly do that as well. But for now, thanks for watching, and we'll see you in the next one.